Here is an explanation on what device we used to do the testing after actuating our compressed air racing car. In our design, we use an 18mm PVC tube which matches with this commercially available high-pressure cylinder. The size is universal. In the early stages, in order to save students from increased costs due to large usage of high-pressure cylinders, so in the early stages, students can instead use this manual pumping device for simple testing. Its concept is like this. We insert the PVC tube onto this valve seat for quick release. There is a pressure accumulator over here. We pump the air from the air pump into this pressure accumulator. And then using this unidirectional valve for quick release, we can instantaneously release the high pressure air from the accumulator, which will cause a high pressure reaction. Therefore, our compressed air racing car will be launched instantaneously. Using this method, everyone can perform testing as much as possible in the early stages, so there won't be a need for the high-pressure cylinder. In addition, regarding this high-pressure cylinder firing mechanism, if you don't have this commercially available device, the teacher has provided this in our online resource. We can make our own by 3D printing these parts. Then students can buy a screw rod and spring, and we can use this with the same concept as an air pistol. We use this spring to instantaneously push the screw rod forward, and there is a nail here that serves as a firing pin. If our high-pressure cylinder is placed here, as I release this trigger, the high-pressure cylinder will be punctured by the firing pin at the front, and the pressurized air will be released. When installing the cylinder in our compressed air racing car, it will be launched with speed. This is a manual firing mechanism. If students have an original manufacturer equipment, it is electric, and after we fasten the spring, like this, there is a solenoid release switch here. All I have to do is press this switch and it will instantly release the firing pin into the cylinder. So our compressed air racing car is installed onto this connector. Since the design of each car is different in height, it is designed to be adjustable to match the height of our car body. After adjusting to the appropriate height, we fixed it tightly, so each student can design their compressed air racing cars with different high-pressure cylinder heights. Next, we fasten the spring. There's a fail-safe safety mechanism here. I will leave it open first. During this testing, we wait for the timer to be installed and set. We wait for the teacher's or the referee's instructions, and then we press our actuator switch, and it will push the firing pin to puncture the cylinder. At this time, our compressed air racing car will instantly have a lot of energy to rush forward. So this is an electronic type actuating device. So, depending on your resources at school, if it is convenient, students can DIY a device like this or DIY an actuator device using a spring and a screw rod. We just need to buy this high-pressure cylinder so we can carry out all the speed measurement activities of the compressed air racing car. Hello everyone, here I will introduce you to the device for measuring the speed of our compressed air racing car. This device was self-made. If students want to make it by themselves, we have provided related resources in our online course website. Its design is composed of a pair of infrared switches. This one is start and this one is finish. It is controlled by the Arduino Uno controller. The relevant program code will be provided to you all in our teaching material resources. Our speed measurement situation is like this. Our compressed air racing car will first pass through the starting sensor, and then after a period of time, it will reach the ending sensor. The distance between the starting and ending sensors will be 20 meters, so later I will roughly explain the starting and ending concept. When testing, students must allow our cable to pass through our guiding groove to ensure that our compressed air racing car will pass through our infrared switches. At the beginning, when the high pressure cylinder is launched, it will first pass through our first infrared switch, as you can see on the screen, and then after 20 meters, it will pass through the second infrared switch. Here we can display the time recorded to travel these 20 meters on this screen, so students can know how fast their own compressed air racing car is. Under normal circumstances, when using the high pressure cylinder, it takes more than a second to travel these 20 meters. Therefore, students must use such an accurate testing instrument when measuring the speed so that they can accurately know how fast their speed is.